Hello everyone. So in this lecture we would be discussing about 0-1 knapsack problem. And what does this question say? This question says that we are given two arrays, a value array and a weight array. So we have some elements, we have a corresponding value to it in the value array, and we have a corresponding weight to it which is present in the weights array. And we are given a knapsack which can hold a maximum weight of W. So what we need to calculate is that we need to find the maximum value of the items we can collect in the knapsack such that the weight of all collected items is less than or equal to W. So again, there is one more thing to note over here. This 0-1 means that we can either choose the item to put in the knapsack or we don't. We cannot just break the item such that to reduce its weight. So now coming on to the example, what do we have? We have 6 elements over here, and the corresponding weights to those 6 elements is present in the weights array, and the corresponding values is present in the values array. So what is the maximum weight our knapsack can hold? It's 10. So we need to devise a function such that it returns 60 in this case. And why 60? This 60 means that the maximum value of the items we can collect in our knapsack such that our weight is not greater than that of the knapsack. So it's 60 over here. And how did we come to 60 over here? By choosing my first element and my fourth element. The same way I can make 60 with the help of these elements as well, by taking my first, second, third and last element. In both the cases, my weight is less than or equal to the weight which knapsack can hold. So if you wanna try this question, so please pause the video over here because I will be starting with the discussion now. So now coming on to the recursive tree directly, what do we see over here? We have our values array, we have our weights array, and we have our knapsack weight. This is the maximum weight our knapsack can hold. What is this KNP? This is the function which will be returning us the maximum amount our knapsack can have. This is the value, this corresponds to the values array. This weight is pointed reference to our weights array. This is the total number of elements that we have. This is the maximum knapsack weight which it can hold. This is the current weight of my knapsack. This is the current value which my knapsack is holding currently. And this is the current index or the element I am traversing. So how do we approach this? Look, for each and every element I have two choices, that whether do I make use of it and put it in the knapsack or I won't be doing it. So that's what would I be doing. So if I branch out in the case when I put my element in the knapsack, so what do I have? My weight as well as the value in my knapsack will increase. So that's what I have done over here. I am simulating that by increasing the current value in my knapsack and current weight in my knapsack. So what was the current value in this call? It was 0 because my knapsack was empty, and these both zeros actually tell that my knapsack is currently empty. So what does this mean? If I try to include the element present at 0th index, so what is the weight of that element? That's 1. So I have increased my weight by 1 and I have increased my value by 20 because the value corresponding to my first element is 20 over here. And I would be saying yes, I have included the element. Now I am going to my second element. What does this branch mean? This branch means that I haven't included my first element. So how will I simulate that? By not increasing neither my weight nor my value in the knapsack, but I would be incrementing my index. This increment in the index means that I am done with all the previous elements. Just tell me from here till end of the array, what max can I hold? The same way, what does this mean? This subproblem means that currently I am holding a weight of 1 and a value of 20 in my knapsack. So starting from this index 1 till end of the array, just tell me what amount I can still hold in my knapsack, or what is the max amount I can hold in my knapsack. So that's what I would be doing. I would be again recursing that I would be including the element or I would not be including the element. So if I include the element, so what is the weight of this element? It's 2 over here. So that's what I did. I have added 1 plus 2, 3 over here. What does this 3 signify? This 3 signifies that I have a total weight of 3 till now in my knapsack. And what is the value to it? The corresponding value is 5. That's why I have increased this 20 to 25. And why did I do it? Because I have included the element, this second element, in my knapsack. And if I do not include it, then what would I be doing? What would I be left with? I would be left with the same value and same weight as of the previous recursive call, but I would be having an incremented index. And what does this index mean? That I have done with my 0 and first element. Just tell me starting from second index till end of the array, what is the max which I can hold in my current knapsack. So if I come to this recursive call, so what would I be doing? I would be again including the element present at 2 and not including the element present at 2. So if I include it, what would I be having? I would be having KNP of 6, 35 and 3. Why this 35? Because if I include the element, so what is the value corresponding to this 35? What is the value corresponding to the item present at this index? It's 10. So I would be adding that 10 to this 25 and hence my value becomes 35. So what does this problem mean? This problem says that I currently have a weight of 6 in my knapsack and I have a current value of 35 in my knapsack. So now starting from index 3 till end of the array, just tell me how much more can I hold in my knapsack, or what is the maximum value can I accumulate in the knapsack. So that's what I would be doing if I just try to include the element present at index 3. So what would I be left with? I would be calling KNP 14754. And how did this 35 become 75? I think you might have got it by now, because I would be adding the value of this element. So what was that? That was 40. So 40 plus 35 becomes 75. And what is its corresponding weight? It's 8. I am talking about this index 3. What is its corresponding weight? It's 8. I would be adding 8 to this 6. Now I have a weight of 14. But this is my base case. And why is it a base case? What was the total value which my knapsack can hold? It was only 10. But now I have a weight of 14. Till all the elements, if I choose my first element, if I choose my second element, if I choose my third element, and if I choose my fourth element. So what is the total weight? That's 14. This branch from this root node to this leaf node represents this only, that I have chosen all the elements till now. So what is the total weight I have accumulated? That's 14. But my knapsack cannot hold it, and hence I would be returning int min over here. And what does this int min signify? This int min signifies that I have totally now gone out of bounds. Whatever the weight I have collected till now, that cannot be accumulated because due to my weight constraint of my knapsack. So what would I be doing? I would be then switching on to this branch, and what would I be saying? That okay, I did not include third element, so I would be having the same weight and same value over here, but I would be having an increment in index. So what does this subproblem say? This subproblem says that currently I am sitting at index 4. So just tell me how much more can I hold in my knapsack such that my value can be maximized. What is my current value? That's 35. What is my current weights? That's 6. So on which element I am on currently? I am at index 4. So what is the value it's holding? It has a value of 15. So if I include this element, what would I be having? My value would become 50. But my weight would be again adding 7 to it. So 7 plus 6 become 13. But again 13 goes out of bound because my knapsack cannot hold it. And hence I would be returning int min again. These both are the same base cases. So what if I do not include it? So what would I be left with? Now I am sitting on index 5 over here. But what is the current weight and value in my knapsack? The current weight I am holding in my knapsack is 6. The current value which I am holding in my knapsack is 35. So what would I be doing? If I include the element present at index 5, so what would I be doing? I would be adding my weight and value to the knapsack. So what is the weight? That's 4. So 6 plus 4 is 10. And what is the value? That's 25. Then 35 plus 25 60. So what does this subproblem say? This subproblem says that I have a value of 60 in my knapsack and I have a weight of 10 in my knapsack. Starting from index 6 till end of the array, just tell me how much more can I hold. But can you see that I am now out of bounds of the array? Do I have any element present at index 6? No, I do not have it. So what would I be returning over here? I would be returning whatever the value currently I have in my knapsack, because now I am not left even a single item. So what would I be returning for here? I would be returning that whatever the value currently I have, I would be returning the same thing. And what does this 60 signify? This 60 signifies that if I choose the element present at index 0 and then at 1 and then 2, but I do not choose the element present at index 3, I do not choose the element present at index 4, and I choose the element present at index 5, then I will get a value of 60 in my knapsack. This 60 represents that. This is actually a path. This is actually, you can say, this is actually a subset over here. I am creating subsets and then checking, okay, which of the subsets will give me the maximum amount, such that all the accumulated weight is again less than equal to my knapsack, or what the knapsack can hold. So if I choose to include the element, I get a weight of 60. If I do not choose the element present in index 5, then what would I be left with? I would be saying, okay, just tell me starting from index 6 till end of the array, how much more can I hold in my knapsack? Currently what I am holding, as I didn't choose the element present at index 5, so I would be sending the same weight and same value because I didn't add anything to it. So what am I left with? I am left with this 35 as my value in the knapsack and 6 as my weight. But again 6 is out of bound, so same thing, I will be returning 35 over here because this is the current weight I am holding. So what would be the max of it? Because again, what is the problem? The problem is I need to calculate the max weight my knapsack, max amount my knapsack can hold with my weight constraint. So what is the max of it? It's 60 over here. So I will be returning 60. Then the answer to this subproblem is 60. Then again max of int min 60, it would be 60 over here. So again the max of int min 60, it would be 60 over here. The answer to this subproblem 635.3 comes out to be 60. And again, what does that 60 signify? That 60 signifies that with the help of all the branches till leaf node over here, starting from this root node till the leaf node, the max I can hold is only 60. That's what this 60 signifies. So if we just say, okay, how did I achieve this 60 and what were the elements involved for achieving this 60? So what I can say, I included my element present at 0th index. So what was the value to it? My value was 20. So if I just choose it over here, I included a value of 20. Then did I choose the element present in index 1? Yes, I chose it. That's why I would have come over here. That's why this 20 would become 25. This one would have become 3 over here because I would have chosen the element present in index 1. So I chose the element present in index 1 as well. So what's its value? It's 5. Sorry. So what does this mean? That I chose the element present in index 2 as well. So what is the value present in index 2? It's 10. Now, did I choose the element present in index 3? No, I didn't choose it. Because if I would have chosen it, then I wouldn't have got 635 over here. I would have added the weight and value of this element. But if I would have done that, then I would have gone beyond my knapsack weight, and hence I wouldn't be recursing for this one. So what else I did? I did not choose the element 3. Did I choose the element present in index 4? No, I didn't choose it. That's why I came over here. But did I choose the element present in index 5? Yes, I chose it, and hence what is the value at index 5? It's 25. So it is this one. So what are these? This is my first element, this is my second element, this is my third element, and this is my last element. With the help of these elements, I made a value of 60, and this is the max which my knapsack can hold. But this is not the complete recursive tree. I recommend you to just branch out for each and every subproblem so that you can see overlapping subproblems and the optimal substructure of this recursive solution. But we can easily see that we do have optimal substructure and we have overlapping subproblems in over here. So in the next lecture, we will be looking at that how to solve this problem and how to optimize this problem with the help of tabulation approach or bottom-up DP. So till then, thank you.